First few slides that I'm going to go through, you don't need to take pictures of, you don't need to write down, just listen because it's going to be review. It's supposed to be review, okay? And I'm going to go through them fairly quickly, just as a point of reference before we actually get into it, okay? So, if you recall, we have lots of different types of curves, and here is the normal curve. We looked at that. We called it the perfectly bell-shaped curve. One of the things to notice here is that the mean, median, and mode are basically the same. So that's why it gets centered. Okay. Down here we have a negative or left skewed graph where the mean is left of the median. Okay. Over here we have a positively skewed graph or right skewed because the mean is right of the median. Okay. Like I said, we've talked about this before. This is not the crucial part of what we're doing in Chapter 6, but I wanted to show it to you as a point of reference. And I'm going to overlay on this because we've also seen a different type of normal graph before that looks like this. We've worked with this before. And what's important here is to understand, again, our mean is the middle. We're 1 standard deviation, 2 standard deviations above, or 1, 2, 3 below. That's really what this says. This you probably want in your notes. It's probably better to screenshot it from your book than to try to take a picture of this screen, but I'm going to leave that up to you. Okay? You want to put this in your notes, and I will let you do that, and we'll talk about what's going on here. Okay? So remember when we talked about 1 standard deviation away from the mean was about 68%? Notice that each section is split up. And now we're going to get into more particular decimal places. 34.13, it's really 68.26%. Then this section here is 13.59%. And when I'm saying percent of the entire graph. And that the entire graph is 100%. Okay, and that's sort of a key concept that we're going to do in 6.1 when we keep talking about percent of the graph, or we're going to talk about area of the graph. We're talking about area percentage based on the entire thing of 100%. Okay, and as we move forward into 6.2, knowing how to convert these standard deviations and figure out what those values actually are is going to be important. Okay. The z value is going to be the number of standard deviations away from the mean. So we've talked about z values before, and we're going to be using z values again in this section. So in this particular case, because we don't actually have data, this would be the z value. This would be the z value. These numbers down here, and that's why I put that in the box. That's going to pop up any second now. There it is. Okay, those are the z values. So they coincide with the standard deviation in terms of their placement, and when we get to 6.2, you're going to see a little bit more of what I mean. But those spots on the graph will coincide with the z values. Value, we talked about that before. It's going to be the same idea. Yeah. How to use table E, find the area. On the next screen, there's actually 3 different procedures that are all going to be, and I'm going to show you one at a time. So if you decide to take a picture of the screen versus a screenshot in your book, wait until I have all 3 of them up there. So here's the first one. Again, this is also on page 305. So when you're finding the area of the standard normal distribution curve, and we're looking to the left of a z-value. So notice here, they picked out a particular positive z-value. If we're trying to find the area to the left, all you do is look up the z-value in the table. And the coinciding number that goes with that z-value will tell you this area. Okay, same thing here, even if z is negative. If we're looking for the area to the left, you just look it up in the table. Okay? And think about it this way. We read from left to right. So when we're looking for this value, it's going to be everything behind it. Okay, that's the first one. The second one is when we're looking to the right. So really what we look up in the table is we look up the spot that's empty. So when I look up this z-value here, or this z-value here, the table is going to give me the empty value. The table always gives me the value to the left of the z-score, or the z-value. So when I'm looking for the area to the right, what I actually do is I take this empty space and I subtract it from 1. Okay, that's how I come up with the area to the right, because the z-score gives me everything to the left. Does that make sense? Okay, so again, anything to the right of the z-score, the area to the right, you're just subtracting the empty space from it, since all probabilities have to add up to 1, since all area in this case is 100%, same idea. And now here's the last, so if you want to take a picture of the screen now, if you didn't screenshot it, now would be the time to do that. The other case that we're going to look at is finding the area in between two z values. And all you do is you look those values up in the table and subtract them. Okay, subtract the one on the right. And that goes first, so it's the higher z value minus the lower z value. Okay. So we've got 4 examples, and we're just going to learn how to use the examples to use the table and to come up with those values. A couple things to keep in mind as we look up those values. The values are all going to be decimal places, 4 decimal places. We can convert it to percent, and those percents also represent probability. So if they ask for the probability of a particular z-score, they are also asking you for the area. That's the same thing. Okay? So if you've figured out a way to split screen to get the table E up on one of your screens, great. If you haven't done that yet, please do that now, because we're going to need that table E to do these examples. So have them both available on your screen so we know how to use it. Okay? So here's the type of problem you're going to see. It's going to say find the area to the left of where z equals 1.99. Now, I'm going to show you the graph just so you can picture it, but you do not need to draw the graph in your homework unless it says, and I'm pretty sure they don't say to draw the graph. So understand the middle of the graph of the normal distribution is always 0, right? Because that's where the mean is, and the z-scores represent the number of standard deviations away from that mean, okay? So I know that this is going to be the right, and it's going to look like this. Okay, so the 1.99 is to the right of 0 is what I meant, sorry. Now, in this particular case, am I trying to find the area to the left of the z-score or to the right of the z-score? To the left. Which means all I've got to do is look this up in the table, and the corresponding value is the answer. Okay? It's that simple. So, now the question might be for you, how do I read the table? And that's what I'm going to show you how to do next. So in the table, on the side, what you're going to do is you get the first 2 numbers. This 1.9 is the vertical column on the side, and then you go across the top to 0.09, because when I add these together, this is what I get. So essentially, what you're doing is you're chopping it. Okay? I'm taking the 1.9, that's on the side column. Then I'm taking the 0.9, and that's on the top. And just run over, line them up. 1.9 on the side, 0.09 on the top, match them up and find that value. Okay, so do that now. and then write it down, and that's your answer. Okay? So I'm going to jump out of this program real quick, and I'll go over to my, my table so I can make sure that we're all on the same page and we can look up that value. Okay, so it seemed like we did okay finding that value in the table. Okay, 0.9767. And here's what that means, okay? That means that 97.6% of the area is less than that Z value. So obviously I'm missing some of the 100% here, but I have most of it. And what we're saying is that we can find the exact amount of area of that normal curve from that table E. So there's three ways to represent it. One is as a decimal, 0.9767. That's how much of the area is shaded and is less than 1.99. Okay, we can express it as a percent. The other thing, as I mentioned earlier, was it can be probability. So sometimes you'll see a problem that's expressed like this. Find the probability that Z is less than 1.99. They're all asking the same thing, and typically when we represent probability, we do write it as a percent. Either one is fine though. They mean the same thing. So when you come across those exercises today in your homework, know that if it's asking you this, it's asking you the same thing as left. Okay, if this was greater, then it would be to the right. Okay, if there was an interval inside here, then it would be the two values and you're trying to find in between. Okay? Any questions? All right. Let's look at one to the right. Oh yeah, the probability would have been the same thing that I just said. Okay, so let's look at one to the right. Okay. The area to the right of Z equals negative 1.16. And just for a visual, this is what it would look like. Okay. So this is a situation where the table E is not going to give me this area, right? It's going to give me the unshaded area because the table E always gives me the Z value to the left. So it's going to, when you look up negative 1.16 in table E, it's going to give you the area of the white region, which is not what we want. We want the complement of that. So I'm going to take whatever this Z value is because this, I'm going to basically what I'm doing is I'm going to subtract this area from 1 to get this area. Okay? Because, and I say subtract from 1 because table E gives it to me in decimals. Okay? So when I look up this Z value in the table, the number that it's going to give me in the table is actually this area. Okay? So because I don't want that area, I don't want it to the left of negative 1.16, I want it to the right, I just take that value and subtract it from 1. So go ahead and look that value up. So that's going to be on the first page because the first page had all the negatives. Basically the first page had everything to the left of 0. And look up that value and then we'll see what you came up with. That's a good question. Keep in mind something. When the mean equals 0, the mean splits the curve in half. So at 0, it's always 0.5. Okay, keep that in mind. If the Z-score is 0, the area is always 0.5, either side, because it splits it right down the middle. All right, what did you get for the Z-score or Z value? The area for the Z value of negative 1.16. Yeah, what did you get? 0.1230. Okay, so what we have to do. So that's this area. That 0.1230 is the area for this. This is not the area I want. I want this area. So I have to subtract it from 1. Okay? You have the answer? Is that okay? Just hold on a sec. So again, because the area to the left is what they give us, we're looking up negative 1.1 on the left, 0.06 on the top. Okay, so let me write that in just in case. Negative 1.1 on the left and 0.06 on the right. That's how you're looking it up in the table. Okay. All right. So then when I subtract that, of course, I get 0.8770 or 87.70% is to the right or greater than. So again, if they put it in probability form, it would be that way. Okay. Yes, you have to write this part. Is the area to the right of. Yeah. Area to the right of negative 1.16.
Do you have to write the decimal and percentage?
No, I'll take either one. If it asks for probability, write it as a percent.
Yeah.
Okay. All right, one more example before we get into the reverse. So the last example we're going to go over is I'm going to give you the area, and you got to find the z-score. So we're going to do it sort of reversed way. Okay. And I want you to do this one. So this one's an interval. Okay, the area between positive 1.68 and negative 1.37. Okay, so again, what we're doing, what it would look like on a graph, I'm going to find the table E value for this, and I'm going to find the table E value for that, and you're going to subtract them. Okay? Find the table E value for this minus the table E value for that. So go ahead and do that. So again, I'm taking the table E value for the right, meaning the one further right, and the table E value for the left, and you're going to subtract them. Now, here are the values you should have gotten. Now let me explain why we don't have to worry about am I subtracting from 1 or anything like that for the interval. Okay. See this, the table E value for 1.68 is everything to the left, including the white space. Okay. So when I look up this value, the area is going to give me all of this, including this. Okay, which is too much, right? I need to chop that part off. Well, this area, again to the left, is the white space. So when I take the table E value for 1.68, I'm including the white space. When I then look up the value for negative 1.37, I subtract it from the whole thing and I essentially chop it off. That's why we don't have to worry about the subtracting from 1. I'm taking this area away from the whole thing when I find this value. Okay? That's why you don't have to do those subtracting from 1, even though it's to the right kind of thing. The reality is I'm going all of it to the left and all of this to the left, but I'm just going to subtract the two from each other. Okay? So there's your values you should have gotten. How many had that? Okay. So when there's an interval, all you gotta do is look at those table values and subtract them. Straightforward. All right, let's look at one where I give you the area, and you got to find the value. So you could say it's in between, the area in between the z-scores. Okay. So in this problem, I'm looking for, and this is not in your book anywhere, I kind of made this one up, so if you want to take a picture of this, go for it. So the type of problem you're going to see is either it's going to be to the left or to the right of the z value. So when you get to ones that are to the right, remember the value that you look up in the table is going to be the complement that you want. So let's talk about this one first, and I'll explain what I mean by that. You have a question?
Yeah, on the last one.
Yeah. All right. So in this problem, since it's to the left, this value, you can look straight up in the table, and it's going to tell you the z-score. So what you need to do is go on the table and find this value, and then line up the left side and the top to figure out what the z-score is that goes with it. Okay? So do that, and then I'll talk about what happens when you have one to the right. One of the things that's helpful when they give you the picture, okay, is that you know which table you need to look at. Do I need to look at the positive table, or do I need to look at the negative table? Which one am I looking at here? The positive one. Because I'm to the right of 0, I know z has to be positive. So you're looking at the second page of the table. If they were looking for a value over here to the left of 0, then you'd look at the first page of the table. Always write the 4 digits. Even if it's, you know, at 0 where it's 0.5000, we always write 4 digits. Okay, so that part will be on the, for chapter 6, we're going to be on the same page. If you write a decimal, it's going to have 4 places. If it's a percent, it's going to have 2 extra places every time, even if they're zeros. Okay? How many of you found the value? Okay, what's the z value that corresponds with 0.9505? 1.65. That's all you got to do. Now let's understand one thing, okay? Just to talk about it, because sometimes it'll say, it'll shade, let's say it shades this instead and says, I want the area of that, right? If you try to look up this area, it's actually going to give me the same thing over here, right? Because the z value, the table E only finds values to the left of that z. So if you look up this area, whatever it is, I guess it's, this would be, what's 1 minus 0.950? So this is 0.0495, is that right? Did I do that in my head right? That's how much is left to make it 1. Okay. Your silence tells me I did it right, or you don't care. If it says I want this, okay, you're actually going to have to look up if it says to the right. Again, if this is to the right, you would actually have to look up because the z-score is still going to be this. So I would actually have to look up 1 minus this if it's to the right. So when it's to the left, like this problem was, you can just look up the score and figure it out. If it's an area to the right, and it gives you it, you have to go 1, because if I look this up in the table, it's going to give me a negative value over here. We don't want to look this up when I go to the right. When I go to the right, you got to subtract it from 1 to look up that value, and then it'll tell you the correct value, okay? So be careful what I'm trying to tell you. There's only a couple problems. I think I gave you 4 problems like this. 2 of them are to the left and 2 of them are to the right. When you get to the ones that are to the right, make sure you take that value, subtract it from 1 before you try to go looking it up on the table. Otherwise, you're going to get a negative value, and that's not what we want. Okay? Questions?